Welcome to Master of Science with host Professor James McCanney. The good professor's career spans 50 years as a university teacher, scientist, and engineer. Each week, he will explore the rapidly changing world of science as many long-held theories are crumbling under the weight of new data. He will cover the fields of geology, archaeology, meteorology, oceanography, space science, astronomy, cosmology, biological evolution, virology, energy, mathematics, and more. So please welcome the host of Master of Science, James McCanney.
Good evening, everybody. James McCanney here, and tonight we are going to be talking about abiotic oil. Now, we're also going to be talking about something called primary water. So these are things that supposedly happen deep underground, and let me just preface this discussion. A number of people have been asking about these topics. They wanted me to cover it. And you first have to understand that all of the theories for where oil comes from stem from one basic assumption, which is completely incorrect. And so we'll get into that. But that assumption is that the earth did this all by itself, that there was no outside help. And that's where the error comes in. And also, the issue is that the standard theories for where water and oil come from, people are finding out they don't work. So what are those theories? Well, generally in terms of water, the standard theories can't tell you, because supposedly the earth formed all at one time 4.5 billion years ago by a collision process where material was orbiting this proto-sun, as they call it, and all this material collapsed together. Well, what happens when all this material comes and collapses together? It creates a lot of heat. And so the volatiles, such as water, such as oil, hydrocarbons, basically go away. The gravity is not sufficient, and so as this accumulates, supposedly, then you're left with this kind of hot, dry entity which comes into a circular form, a spherical form, because of self-gravity. In other words, it was so hot that it was so molten that it literally formed a globe, a ball, because of the self-gravity, in other words, gravity pulling it together. And then but this is hot, this is molten, so you're not going to have water, you're not going to have oil either in the planet or on top of it. So now with the theory, the standard theory, you have to wait until the planet cools. And when the planet cools, now you have to somehow get the oil in the water. Where does that come from? Well, the standard theory for oil is that eventually there was plant life that grew. Well, how did that grow if there wasn't any water? So what came first here, the chicken or the egg? But the oil theory is standard one that doesn't work, which was, by the way, promoted by the oil companies to make you think that there was a limited supply of it, that you had to pay a lot of money at the pump to get a piece of your oil to put in your car and drive your SUV up and down the road. So how many times have you heard there's an oil shortage? Surprise! Good grief, there's an oil shortage. So now you have to pay more, and people line up, and you can only get 5 gallons at a time, and people are fighting, trying to get their 5 gallons of oil. And then all of a sudden, back to normal. There was no oil shortage. There never was, and all of the oil shortages and all of the price hikes that you pay, inflation, is all contrived by the oil companies. So they have this convoluted story. But the idea that oil comes from fern forest and dinosaur bones was originated by the originators of the oil industry. Okay, so if you have fern forests enough to make all the oil that you find on the planet, That's a lot of fern forest. Let me tell you, that's millions and millions of years. But nobody has ever been able to show you how a fern forest, with the material dropping and decaying, somehow turns into oil. That magical formula has never been accomplished. That would probably be a Nobel Prize winning chemical discovery. If you could take dirt, simply compress it and make it into oil and sell it for money, or rock, or whatever you have, and make oil and then convert it into gasoline, that'd be a pretty good trick, but nobody's ever done it because it's, well, let's put it this way, it's BS. Okay, well finally people started figuring this out, so they had to come up with a reason for oil. So along comes abiotic oil. Well, biotic oil is the kind that comes from fern forests, allegedly. Abiotic oil is oil that does not come from fern forests, but comes from materials being compressed deep in the earth and forming oil. And all of a sudden you have oceans of oil under the surface of the earth being formed by compression. Well, how does that work? You need the carbons and the hydrogens, and there again, hydrogen is the most volatile chemical in the universe. It's the most abundant, but in this hot, dry rock that formed originally, there ain't going to be any hydrogen either. So there you got some contradictions, but don't let that stop the abiotic oil people from telling their tale. So it comes back to another issue of water then. Where did the water come from? In standard science, cannot tell you. They strike up the theory that comet nuclei, which supposedly are dirty snowballs and have a lot of water on them, well, let me cut that off at the pass, because we have visited, what, a dozen comets now? There ain't no water, there ain't no ice, there ain't no snow, and there's nothing coming off the nucleus. The European Space Agency landed on the nucleus of a comet called 67P with a long, Russian name attached to it, but 67P is the designation for the comet. They landed on the nucleus, and guess what? There was no water, there was no snow, there was no ice, and there was nothing coming off the nucleus at all. Nothing at all coming off the nucleus, certainly not water. To the point that the European Space Agency scientific team got up on the podium and literally kind of with their heads hanging down and kind of mumbling under the microphone that comets are not dirty snowballs. In 2018, the head of NASA Science, this is top man at NASA in terms of science, proclaimed that they now know that comets are not dirty snowballs. They're basically hot, dry rocks, and what they found with the Philae lander on Comet 67P was basically dry sand made out of organic chemicals, organic compounds, but no water, not a drop of water. Additionally, there have been other experiments where they had the deep impactor crash into the surface of a comet, and a lot of dust came out, and then leave it to NASA, never a straight answer, to come up with the idea that, oh, all this water came out of the hole. But what did they see? They didn't see it come out of the hole because they had cameras trained on that impactor to see what was going to come out of the hole that was made by the impactor, and nothing came out except dust. But the comet generated water in the tail because comets are not dirty snowball. Where's that water coming from? Well, my theoretical work shows you that comets are the discharge of the solar capacitor. So when that impactor hit, it also sparked, kind of like a spark plug, it created a larger electric field around that comet. It actually created a bigger discharge, and therefore the tail augmented, and there was more water production in the tail. But that water is coming into the nucleus, not going away. And what happens with the small comets is it doesn't build up any of that water on the nucleus. It comes in, the H2O which is ionized, positively ionized, gets neutralized by the electron cloud that's around the nucleus, and they go floating away as what they call neutrals, neutral water. Not charged water, but neutral, electrically neutral water. Okay, so anyway, comets are not dirty snowballs. So, but even if they were, let's play devil's advocate here, even if they were dirty snowballs, when they came crashing into Earth to deposit their water on planet Earth, which is dry, it has no atmosphere, it's hot, and these so-called ice ball comets come crashing in, guess what? There's a lot of heat involved, and that water is just going to go whoosh, and it's going to go away. It's not going to land on Earth. So the comet providing water to Earth theory does not work. You have to account for little things like, for example, why does the ocean water have salt and the fresh lakes don't? Well, did some comets just happen to hit over there in the ocean and they had salt content and they didn't hit over here? Nice and neat. I mean, the stories just get so silly that you can't, I mean, silly is the best word you can come up with. Okay, so at any rate, the whole issue here is, where did water come from? So, to the rescue come the people that tell you that it was all created down there under Earth, and it just was, water is what? Oxygen and hydrogen. So, where did the gases come from that were somehow locked down in the Earth? Well, they can't tell you that. They don't even talk about that, because it's really an impossibility. Oxygen is a gas, especially at the temperatures of the early Earth. So there is no oxygen in the Earth of any kind at all. It might be attached to iron, oxidized iron, or oxidized sulfur, sulfur dioxide, iron oxide, like that. But it's not going to break loose to form water. It's very tightly bound. So where does the oxygen come from? Where does the hydrogen come from to make water deep underground? And where does the carbon mixing with hydrogen come from to make the hydrocarbons, which we call oil? So at any rate, none of this makes any sense. So you have to understand that the idea that somehow water and oil formed deep underground with pressure, with available chemicals that were in the ground, basically free hydrogen and free oxygen, which wasn't there, these theories really do not work on the surface. And so I'll talk about where these really come from. And there is oil down deep in the earth. There is water down deep in the earth. But how did it get there? And this is what I started with. This is the very beginning topic, that when you look at what people have to theorize with, this comes top down from the astronomy community, which says that nothing happened to Earth after its formation. Well, if you're left with that mantra, then you're in big trouble. You're in big trouble because you're left with this hot ball that's dry. It has no volatile chemicals in it at all, and there's no atmosphere, and there's no water, and there's no, there's nothing there. It's a hot, dry rock that's molten. It forms a globular ball shape because it's so molten that it pulls itself into a ball by self-gravity, because it's like liquid rock. That's how hot it is. It's like a volcano that's spewing lava. That's how hot the Earth was, but all over. So anyway, we have a break coming up here. I'll be back in just a couple minutes and to discuss this topic a bit more. Okay, so we're going to take a couple segues here in this discussion, and then we'll get back to the topic of, yes, there is water. Yes, there is oil, a lot of it underground. In fact, let us put it this way. When the oil was first discovered and used that we know about, it was probably in the Orient. China, probably China used it a lot sooner than what we are aware of. But the idea was that in the Mideast, where there is abundant oil, they found it on the ground in pools. It was pooling on the ground, and they took it and they found out that you could burn this. It was flammable. It was useful. And of course, one of the very first things they did with it was to use it for warfare. They'd take big catapults, and they would take material and bind it all up and have it soaked in oil. And then they would throw these over city walls. Can you imagine being under attack in a city and you're trying to defend the city over the walls that were built around the city, and all of a sudden in come these huge balls of burning material full of oil, and when they hit they would explode and everything near would be burning. And of course there was a lot of flammable stuff inside a city, hay and feed for horses and wood and all kinds of other things. So it was probably a pretty scary weapon, and of course it's been used for warfare ever since. But that was one of the first uses, and then it was refined. They learned how to take and refine it, get the kerosene, the gasoline, the other extracts out of the oil. But they first found it in pools on the ground, and then when that ran out, they dug down a little bit and they said, well, gee, it's down here in the sand too. And the farther they dug, the more they found. Well, okay, that's the real history of oil, and that happened in the Mideast, what we call the Mideast now, in around 1200 AD. That is about the time frame. And going back to past civilizations we don't have any record of, probably they used oil. And now if you look around the world, you find the tar oil in Venezuela. You find the sand oil that is in Canada, for example. And you find reserves of oil, for example, in the Gulf of Mexico. A lot of the oil is what we call crude oil, which is very thick. In other words, let's break it down to the chemical level. The crude oil is a long hydrocarbon chain. The tar is a much longer hydrocarbon chain. And by the way, you find this on the surface of comets, baked on to the surface of comets. So there's hydrocarbons in outer space. In fact, one of the primary places you find oil is in the tail of comets. And that's what I'm going to talk about very soon. Because none of the theories for primary water or abiotic oil and water that's somehow formed deep underground, none of them hold water, because they all assume that the Earth did this all by itself. And given that model that Earth formed all at one time and nothing has happened since, there is no hydrogen, there is no oxygen that's free underground to form water. Then the same with carbon and hydrogen. There is no free hydrogen to form with carbon to create oil, even if it's under great pressure. That's like a myth. You know, let's have somebody prove that in a laboratory. Let's get some material that's down in the earth, compress it, and let's see if you can make oil. These people are all talk, no action. And so, unfortunately, and that's a bit harsh. That's a bit harsh because I know these people, and I know some of them very well, personal friends that propound the abiotic oil or the primary water. They're good people. They're not, I don't want to be offensive, but sometimes the truth hurts. There is no source of hydrogen under there to form water, nor to form carbon-hydrogen compounds. In fact, the same with nitrogen-hydrogen compounds or sulfur compounds. The hydrogen that is there is locked up in, okay, so we'll talk about other situations in outer space. Okay, let's talk about some of the other planets. Mars has traces of water that are recent. And if you listen to NASA, they're going to tell you that this happened billions of years ago. So that is the standard story for Mars. However, geologists who work for NASA, and I've talked to these people personally, they will tell you that the water erosion that they see is recent. And the middle part of my book, Principia Meteorologica, the Physics of Sun-Earth Weather, which, by the way, is written for the general public. The whole middle section of the book is dedicated to surface water on Mars. And you can see the rivers, you can see the deltas, the river deltas that float into the ocean. You can see the oceans where there are far fewer craters that are craters from things coming in from outside. And why are there fewer craters in the ocean areas? Because they hit the water and did not make surface craters. They were like, they were stopped by the water, so to speak. And so they didn't make many craters. And so you can see all of this pristine riverbeds all over the surface of Mars. And so we also know from the ancients that Mars was a water planet in recorded history. And what happened? There was a comet that came by. It was Venus the comet. And it came by and it extracted the water and the atmosphere from Mars and left the red hulk of a planet that we see today. And also it turns out that our moon had water. Our moon had, if you look, there's water erosion on the surface of the moon. And it'll cut through craters, etc., which means that the water came after the craters. Or there's some cases where a crater will then break through where the water flow was. But why would there be water on the moon? And I guarantee you they're going to find oil on the moon too. When they start exploring it and start digging around, getting down below the surface, they're going to find oil. And why? Because it's the same source of oil, and they're finding water on the moon. How is there water on the moon? Where's the abiotic processes on the moon? The situation is there's no atmosphere on the moon, so there's very small traces on the moon. And that's also an indicator of what I was saying in the very first place, because the moon gets direct sunlight. It has no atmosphere. It really, and so there's nothing to hold the water there. You need an atmosphere to hold the water in place. You need atmospheric pressure, and that's why Earth has water that's in liquid form on the surface. Going to take another little segue here. There's misinformation, and this is so strange. I was talking about the oil shortage that is talked about every now and then, about every 5 to 8 years. Oh, there's an oil shortage. We've hit peak oil. No, there is so much oil on Earth that we could never burn it all. In fact, if we burned it all, we would actually expend the entire amount of oxygen on the planet, and we would be left here dead. And the reason is because the oil does not come from fern forests, and it does not come from abiotic formation deep down in the ground. The same with water. The problem, this is another one of the big problems with primary water theory, is that where did all the surface water come from? Did it all form underground and then came up and formed the oceans? Where did this water come from? And the actual answer is that in Earth formation, let's go back to the beginning. Now understand that planets form from large comets. And the solar system did not form all at one time. It formed one planet at a time, and the comets are becoming planets. Now this is my basic work, and you know, NASA had this story down. They had their story down. They were sticking to it. All of a sudden, they find out that comets are not dirty snowballs. What are they? They're an electrical discharge of the solar capacitor, and when that happens, the material comes in the tail and builds up, especially on the larger nuclei, and it can accumulate. And what happens when that accumulates? Well, two things. The orbit of the planet the comet becoming a planet changes. It becomes circularized, and it becomes that's called eccentricity damping. That's one of the effects of the tail drag, which I've defined in my work. So that's one of the effects, is the tail drag. And the other effect is the circularization of orbit. And so that's why Venus could work through the solar system once it was captured by Jupiter. And we know this from the ancients also, that Venus was originally seen by the ancients after it was captured by Jupiter, and I talk about this in my work. But at any rate, if you look at the planet Venus, which is a brand new planet in the solar system, it has an immense atmosphere, 1,000 times denser than Earth's atmosphere. So it has all these chemicals already in the atmosphere. It has the hydrogen, but it's in form of sulfur-based compounds. And so sulfuric acid and oxygen is also locked in the atmosphere in various compounds. And when it cools down, the hydrogen and the hydrogen and oxygen are going to form water. So Venus already has huge amounts of oxygen, huge amounts of hydrogen, and also huge amounts of carbon. So all of the components are already there in the newly formed planet. And that's the answer, because planets did not form all at one time. The story that doesn't make sense in 1,000 different ways. Let's take another example of why planets did not form all at one time from a rotating dust cloud. This goes back to the Lagrangian Laplacian theory back in the Middle Ages. That's how old these theories are. The idea that comets are somehow an ice ball melting in the sun goes back to Kepler in the Middle Ages. It hasn't changed since, and they're still trying to stick to those stories. But one of the big problems is that when the planets are rotating around this prototype sun, the proto-sun, so to speak, they would rotate backwards of what they rotate today. And so then they have to say, well, something came in and hit each planet, so it rotates forward. These are all technical issues with that idea that all the planets formed at one time. Simply not true. 27 of Saturn's moons are captured. Why not all of them? And literally all of them were captured. Capture is the process by which solar systems are formed. Okay, so the Earth, when it formed originally, it may not have had the moon. The moon may have come, and probably did come at a later time, captured into the solar system and became the moon of Earth during this process. And so the chemicals that make up the water and the carbon hydrogen compounds, what we call oil, naphtha, the ancients called it naphtha when it came raining in and igniting from the meteorites that were coming in at the same time, the burning naphtha, the hail of brimstone and fire falling in from the sky. That's what the ancients tell us, and I believe them, because they're telling us. Now, how could the ancients make up these stories? Because they talk about this all over the world. They talk about the Noah's flood, and so the whole issue is that the Noah's flood, for example, was torrential rains coming from above, and every society on the planet has this same historical record, that there was torrential rain that came from above, and it caused a worldwide flood. The ocean levels rose in some places hundreds of feet. Okay, so now you have a situation where water is coming in after the planet is formed in huge amounts, and that is because Earth passed through the tail of a comet, where there's abundant water, more than abundant water. So now I did some calculations. For example, if we had passed through the tail of Comet Hale-Bopp, now that's a big comet, and it would have taken us about 40 days and 40 nights. And we would have had a tremendous influx of water from outer space. And so that's what happened with the Noah's flood. Once again, you have scientists, geologists trying to say, oh, well, the Noah's flood was simply a land break off of the Mediterranean Ocean where this body of water flowed into the Mediterranean and flooded it. Well, that doesn't fit the narrative. All of the civilizations around the world have the same story of a flood, which was torrential rain coming from up there, coming down into Earth. And if we would have gone through a comet tail, that's exactly what would happen. abundant water, just a flood. And now let's look at Noah himself. And by the way, Noah was not the only guy to survive in his family. That's kind of a myth that he was the only one that survived, but he did survive, and he built an ark, and in the middle of nowhere. Now, if the story of the dike breaking and the water flowing into the Mediterranean, if that were the case, well, then Noah really would not have had to build an ark. Because what would he do? Build it right where the flood was going to come through, where the flood waters from the broken dike were going to come through? And no, all he'd have to do is walk up the top of the next hill with his family and set up camp there. I mean, so, once you start peeling back these stories that come out of standard science, the first layer, they fall apart. They don't make any sense at all. Let's talk about another story that came out of standard science, and it deals with climate change. Anyway, that's a whole topic unto itself, but the primary issue with climate change is control of water. It has always been about the control of water. And we live on a water planet, 3/4, about 75% of the surface of the planet is covered with water, and there are vast clean water, freshwater resources. So one of the issues is that a lot of people live in a dry area of Earth where there's not sufficient rainfall and there's not sufficient clean water for people, mainly because of pollution and lack of the ability to gather the rainwater. I've done studies, water is something I happen to know a lot about. I have a book, it's called Water, you might check it out. It's on the webpage, jmccsci.com. And it talks about the misunderstandings of water on this planet. And we do not have, let me repeat, we do not have a water shortage. We have a water management problem, typically from the governments who mismanage money and water and oil resources and just about everything else that they touch. Space, name something that government touches, and I'll tell you something, I'll show you something where it's mismanaged to the nth degree. And water is one of them. There's a lot of fresh water, and there's a lot of misconceptions, people running around, well, we got to stop cattle from drinking water. That's one of the things you hear all of the time. But the problem is if you stop cattle from drinking water in Kansas, you can't get that water down to the driest part of Peru where they need water. Moving water is very difficult. It's very expensive. And so the kind of the fairy tale idea that if you stop water use here, then it'll solve a problem over there is simply fallacy. You have to use the water locally. I did calculations one time dealing with what if you could take the water from the Greenland ice cap or from Antarctica, the two biggest sources of fresh water on the planet. What if you could take that water, because there's a lot of runoff during the summer periods in those respective parts of the globe. There's a lot of runoff, and it's pure fresh water. So what would it take, and I took an example of a little country called Sierra Leone. It's on the west coast of Africa. What if you could take that fresh water and move it down to Sierra Leone, a population of about 7 million people? It would take 37 oil tankers moving constantly. This is going up, picking up a load, and that's allowing them a couple days to load up the water, filling the biggest cargo ships, oil cargo ships on the planet, 37 of them running full-time, moving back and forth, just to give little Sierra Leone, 7 million people, 5 gallons of water per day, which is absolute minimum amount of water that human beings need. So moving water is not easy. Imagining that you're going to stop cattle from drinking water in Kansas so that you can have water in Peru doesn't work. These are all kinds of fallacies that happen coming out of people that have good intentions but no scientific background. Let's just put it that way. But there's no shortage of water on Earth. Now you can take the driest places on Earth, and the greatest example is in the middle of the Gobi Desert. There's a little country there that developed on the spice route, the old spice route between the East and the Mid-East, where they did trading, Marco Polo, or the Silk Route it's sometimes called, where they moved goods on camels back and forth. And to have a respite place in the middle, this little country had a resource in that they had underground caverns. So when it rained, they dug channels and they allowed all the water that rained to pour into these channels, and they would house it there. So when the camel trains came through, they would give them safe passage, basically, harboring them overnight and then filling their water bags. They became the richest people in the spice route. They became richer than the people moving the spices because they had water. This is in the driest place on earth. So they were industrious. So they said, well, if we could make bigger caverns under the ground, we could capture more water. So they were able to do that, and they dug and dug and dug and dug until they had huge caverns. And every year when the rains came, which was very little, only happened for a few days, they would garner all of this water in the caverns, and that would be their water supply for the whole year. So there's plenty of water no matter where you are, even in the driest places on planet Earth. There's plenty of water if you use a simple method called catchment. Okay, so anyway, let's get back to primary water and abiotic oil. Where does the water come from? Well, there's another little fact of Earth, and that is that it's constantly building up surface area. And this is going on every day. We're bringing in water every day, and we're bringing material like basically the material is falling in to Earth, and this is because the Earth is acting as a comet. And it's, here's the problem. When some people listen to this, they have their minds are so distorted by these incorrect theories that they've been just subscribed to. They've been basically programmed to believe that come out of NASA that the solar system formed all at one time, etc. So when they hear the real story, they're like surprised, they're shocked, they don't understand it. And that happens with top-level scientists, because their brain is locked into this pattern and it can't change. Okay, so that's another major issue here with when you're explaining to people the exact location and source of water and oil. Okay, so where does the oil come from? And we know from the ancients, and it is verified by their observation of brimstone and fire. And this is the hydrocarbons coming in as we're passing through or near a comet tail. And once again, this is coming in every day. But the big source, the big input comes when we pass through the tail of a large comet. And so the hydrocarbons, you can see them in the comet tail. You can see them. The nucleus of comets have tar baked on them. Where does that come from? That comes from the comet tail. It's falling into the comet nucleus. And so you have to understand this. And once again, this show is to present people with the overall details. Now, what you have to do is go back to my webpage and read the materials there. There's extensive amount of material. And unfortunately, most scientists, the worst offenders are people with PhDs. You just can't change their mind. It's locked into place. And so what we have to do is educate a whole new generation of scientists that understand what's really going on in the world. And I'm sorry to say this, but you're not going to get a good education at a university. That's just the way it is. Okay, so talking about climate change, the whole issue of climate change has been control of water. That's what it's been originally. That's what it's all about. And every time you find out something about climate change, the very next line is, oops, all this water, we just don't have enough. when in fact desalinization, in fact I'm working on a project right now, I won't talk about it in public, but with a very large group of people to improve and bring down the energy requirement for desalinization to provide, because 90% of the world's population lives within 100 miles of the coast of the ocean. And so we have oceans of water. Anybody that tells you there's a water shortage, I got a bridge to sell you. It's called the Brooklyn Bridge. The old, when the tourists came off the boat from Ireland or Poland or wherever they were coming from, somebody would meet them and say, look at that bridge up there, I will sell you that bridge. And every car that passes, you're going to be able to charge them and you'll be a millionaire overnight. This is America. And of course, the new bumpkin off the boat would say, well, how much money does it cost? And the guy would say, well, how much money do you have? He said, well, this is how much I have. He said, well, that's what it costs. And so they would buy the Brooklyn Bridge and go up there the next day and start trying to stop cars and charge, only to find out that they had been scammed. And so anyway, if you're not familiar with that little piece of history, if you believe what standard science is teaching today, then I've got a bridge to sell you. That's about the size of it. And all you can do is laugh, because but it's not funny. It's really not funny at all. Okay, so back to the idea of where did the water come from? Where did the oil come from that's underground? And combine this with the fact that the earth is building up topsoil all of the time because it's coming in from outer space. We get, let me see, sometime there are actual numbers on this, the amount of material falling in from outer space on a daily basis, not to mention when we interact with large comets. But it's hundreds of thousands of tons of material on a daily basis coming into planet Earth. And you can see this. This is one of the jokes about the moon rocks also. China just came back with some moon rocks, and of course other nations have gone up to the moon and have brought back moon rocks. Well, the rocks on the surface of the moon have nothing to do with the moon. That's all material that's fallen in from someplace else. It has nothing to do with the moon. So moon rocks are another joke. If you have, a lot of people have paid a lot of money for moon rocks, and if you want to buy moon rocks, I've got a bridge to sell you. Okay, now I'm going to divert the topic to something a little different. When a planet forms, it's extremely hot. And just look at Venus. They have mapped Venus. It has thousands of volcanoes because it's a new planet. It's bubbling hot. And guess what happens to those bubbles that are in the rock? They form huge caverns, huge caverns. Eventually, when the planet hardens and cools down, gains an atmosphere, has water and oil coming in, guess where that water and oil, which is a liquid, eventually ends up? It ends up down in those huge caverns. So yes, there is vast amounts of fresh water. There is a vast amount of oil under the surface of the earth. And then you find the oil also in the coal fields. Some coal fields are dry, what they call dry coal, and some of it is high energy coal, and that has oil in it. Now, what's the difference? Well, the coal comes from tsunamis. When the large comet nuclei come by, it sets up a gravitational wave, and the tsunamis come in and they take all of the vegetation and they slam it up in a valley or at the side of a mountain, and that's where you find the coal deposits that are built up over the centuries. As repeatedly these tsunamis are building this up in the same place, by the way. And that's why, for example, the Pennsylvania coal fields are layered. You'll find a layer of coal and a layer of gravel, then a layer of coal, then a layer of gravel. Thus, repeatedly, these tsunamis are coming in, probably from the Canary Islands. That's how far inland those tsunamis can go, which is another possibility right now. A landslide in the Canary Islands generating a tsunami that comes across the Atlantic Ocean in a matter of a couple of hours and takes everything and just drives it inland and builds up those coal fields on the eastern side of the Appalachian Mountains A byproduct of that is natural gas. And so, at any rate, yes, there are vast amounts of oil under the ground, but there are vast amounts of oil on the surface of Earth also. If you look at the biggest oil deposits on Earth, Venezuela, the biggest, is tar. It's the tar deposits that are in Venezuela, the Orinoco region. You find also the Mideast, vast amounts of oil, and then you look at Canada, vast amounts of oil in the sands. And so where did the oil come from that are the oils that are in the sands in Canada? All of this came in from outside and basically accumulated there as the Earth passed through the tail of large comets. So yes, there are vast amounts of oil under the surface of the Earth. There are vast amounts of fresh water, pristine fresh water if you can get to it. And by the way, a little issue also here is that when volcanoes go off, when they explode, when a volcano explodes, what causes this? Now the standard, once again, standard science is totally incorrect on this. They say that gases emerge from deep in the earth. Well, there are no gases deep in the earth. Anything that is in volatile form has already joined with something under there and formed solid compounds. There's no free gas that's down in the earth. However, what there is under the ground are vast amounts of water. So in a volcanic, as the ground is moving, and it's very correct that the people that are talking about primary water, a lot of what they say is absolutely correct. The only difference is, where did the water come from? It was not formed underground. But when a volcano goes off, what's going on? Well, the ground is shifting. And what's really going on is the water finds a way to get down to the magma. And when it turns to steam, you have basically a steam engine with a small outlet going up to the surface. If you look at something like, say, Mount St. Helens, a recent major eruption in the United States, the whole side of the mountain blew off. That's not because of gases that were latent down inside the earth. It's due to water turning into steam. And this is one of the big problems, by the way, with the Yellowstone caldera, which has blown its top throughout history millions of years ago. But today, it's the water that's in the lake of Yellowstone is a problem, because what happens? With the shifting of the earth, because the volcano is rumbling, the water can seep down, and if that water in that lake turns into steam, you're going to have the biggest volcano the earth has ever seen. And so I have recommended at the presidential level, and I've had people representing me at that level, and to the U.S. Geological Survey, etc., it's saying we have to get that water out of Lake Yellowstone. Because if the water is gone, all there's going to be is a local lava event where the lava will flow around. But if you have that water there, that water is going to sink down into a cavern, touch the magma, and it's going to blow. There have been 3 of these serious supervolcanoes that we know about in history, and all 3 of them had a lake above that caldera. And so this is ripe, and it would take out probably 1/3 of the United States overnight. So it's one of the major problems in the United States, and scientists don't understand this. In fact, NASA came along and said that they wanted to drill a hole and let the water drain down into the hole, thinking they would cool down the volcano. Excuse me, boys and girls, they would cause the biggest volcano that the earth had ever seen. So anyway, absolute nonsense coming out of standard science. Whoever let these people out of their playpen and actually control science, it's unbelievable. Okay, so getting back to some summaries here. Yes, there is water in vast quantities under the surface of the earth. And you see the primary water people drilling sometimes sideways into a mountain looking for primary water. And yes, it's there in vast quantities, and it could solve a lot of the problems of planet Earth relative to water because it's just sitting there, and we could use it up here on the surface. So very good. I just want to make it very clear that the water, the one little piece of the puzzle, and it really has no account as far as getting water. The water is there, not a question. The question is, where did it actually come from? Okay. Is there oil under the earth? Yes, they have found oil deposits 18 miles down. The problem is that when you drill down to those depths, and once again, that's because the surface of the earth used to be 18 miles down. And this oil is trapped down there. Imagine in another, say, 100 million years, when the earth has another 500 to 1,000 feet of surface here on top of what's here today. Okay, well, what we call the surface oil deposits of today, the Orinoco oil deposits in Venezuela, or the tar sands of Canada, or the liquid oil deposits that are in the Gulf of Mexico, all of that will be underground. Eventually, it will also be 18 miles underground, where people can drill down and get it. But the problem is, whenever you get that far down, the pressure down there is like popping a balloon. You have a lot of pressure, and you have one little hole going down there, and guess what's going to happen? This is what the BP oil spill was all about in the Gulf of Mexico. They were drilling too deep, and they have no way of controlling it. So it caused a tremendous pollution event. They couldn't cap the well. So anyway, this is just a summary. I could go on. In fact, I could teach a college, university level course on this topic alone. This is serious business. You have to understand what's going on and how this oil, how this water got there, and the effects of, say, trying to drill down and get it. You have to be careful too if you're near a volcano or if you're near the magma, because you don't want to drill a hole and cause a volcano or an earthquake. This is a big danger for people that are trying to drill into these caverns and holes. Okay, so I hope that makes a lot of sense, and hope that satisfies the people who requested this topic. Okay, I'm going to take a few seconds to talk about the different ways you can support this show. I don't take donations, I don't take government money, I don't have government contracts, I don't have people handing me money under the table to support their agendas. I do this out of dedication and love for what I do, and that goes for my entire career. I've never signed government contracts. Those are, by the way, the bane of science today. Government-supported science has destroyed the scientific industry, and unfortunately it is an industry. So anyway, here are the ways you can support this show. Here's the main webpage, jmcannyscience.com, the short URL, jmccsci.com. And you'll see at the top energy, water, food. So those are products, physical products that you can buy. The water filter, I'll go into all of these. The second one is education. I have my books, CDs, DVDs, educational material. And the third one is this radio show, which will also include a link to my Patreon channel, where you can get the weekly shows directly sent to you, and any other updates. Taking a look here, first of all, under products, you go to the water filter company, JMCC Water Filters. I've been in business for now 25 years and continuing. Started the business around 2000 as a way to support my original radio show, the James McCanney Science Hour at the Crossroad, airing from WWCR Nashville, Tennessee on Thursday evenings, 6 p.m. And now I have my entire product line, my own custom products. The MR5 is the primary product that we sell, whole house water filter. Here's a picture of one installed in a location. They don't take up very much room, but they give you the equivalent of a pure mountain water stream in your home. So hot and cold water are filtered. Here's a picture of the subsequent filter element in the series. It's called the UV sterilizer, 36 inches long. Comes with 2 UV bulbs. Does a final purification of the water in your home. Also, we sell the HI, my own name brand water filter elements, unique on the market. You won't find these anyplace else, available on the jmccwaterfilters.com webpage. Also, we have a commercial line, plumbers, builders, and contractors. Welcome to visit here. We have an entire commercial line of products. Next is the grow towers. These are amazing. You can grow organic, non-GMO food in your house. These are photos of commercial systems here, but you can buy 1 or 2 towers for your home, for your backyard, for your greenhouse, and produce all of the vegetables and fruits that you can eat, plus a lot more. Okay, next, the jmccannyscience.com homepage, educational materials, and I've got 14 books, a number of DVDs, a number of CDs, and some other physical products, the Recalendar Sunstar Clock, and posters. And you can see you can buy these as packages, as individual books, ebooks, and then CD packages and physical products. Here are the original books, and these were printed, some of them between the year 2000 and about the year 2010. But when I write these books, they're written for all time. People will be reading these in 100 years. The original book, released in around 1999, Planet X, Comets, and Earth Changes, contains my original material from the time I was at Cornell University, including peer-reviewed journal articles that were published in peer-reviewed astrophysics journals in 1979 to 81 time frame. And so a very important book, Planet X, Comets, and Earth Changes. And by the way, these are only available on my webpage. Then the Surviving Planet X Passage, Atlantis to Tesla, the Colburn Connection, one of the biggest selling books that I've had. By the way, most of these would be on the New York Times bestseller list. Next is the Principia Meteorologia, the Physics of Sun, Earth, Weather. And by the way, these are written for the general public. Calculate Primes, the Diamond Principle. Okay, I'll quickly go through the rest of these books. A book on comets, very important book. A book on water that discusses the world water situation, another very important book. Then Breaking RSA Codes for Fun and Profit. This goes along with the Calculate Primes series. The next book, Mechanic Wing Generator, World Energy Project. A very important book dealing with world energy situations. And then my discovery in 2015 that the Nazca lines are in fact fractal, large-scale fractal transmission and receiving antennas. Then Principles of Prime Numbers, Volume 1, goes along with the Calculate Prime series. Then 2 very important books, Planet X Update 2020 and The Real History of Man and Earth, Myths, Magic, and Mayhem. I have a number of CDs and downloadable eDVDs. And then the Recalendar Sunstar Clock, a great tool for education and for basically understanding the workings of the solar system and the sun and the moon, etc., and the ability to develop a calendar and clock. And then the 3 poster set. Here's my Patreon channel, patreon.com/jmccsci, where you can support this show and receive the weekly shows updated directly to you. And once again, the webpage, jmccannyscience.com, the short URL, jmccsci.com.
This has been Master of Science with host James McCanney. Join us each week as James will delve into historical figures such as Nikola Tesla, Albert Einstein, and the great mathematicians as we explore the history of man, Earth, and our universe as you've never seen it before. Tuesdays, 7 p.m. Eastern, right here on the Bold Brave TV network, powered by B2 Studios.